This video we are going to discuss about Bohr's atomic model. Bohr's atomic model is based on Rutherford atomic model and Planck's quantum theory. Let us start the postulates of Bohr's atomic model. The first postulate under Bohr's atomic model is electron revolve around the nucleus in a closed circular path called orbit, shell or energy level. If you have seen the Rutherford atomic model, in that Rutherford compared his atomic model to solar system, and he said that similar to the solar system, the nucleus is at the center of the atom and the electron revolve around the nucleus in a circular path, and that path is known as orbit or shell or energy level. Remember, the electron will revolve around the nucleus in a closed path which is known as orbit, shell or energy level. The second postulate of Bohr's is the energy level are designated as 1, 2, 3, 4 or else K, L, M, N. The third postulate under Bohr's atomic model is as the orbit number increases, the size and energy of the orbit increases and the difference between the adjacent orbits decreases. Here two things are there. The first thing is as the orbit number increases. As the orbit number increases from 1 to 2, 2 to 3, 3 to 4, the size of the orbit increases. As the size of orbit increases, the energy also increases. The second thing under this postulate is nothing but the difference between the adjacent orbits decreases. If you consider the example of an atom, here the center of the atom is nucleus and these are the energy levels or the orbits or the shells in which the electron travels. The path followed by the electron is circular, but we are not representing it completely because of the space problem. As the orbit number is increasing, the distance between the nucleus and the orbit is increasing. That is nothing but the size of the orbit is increasing. And one more thing here, you should see that as the orbit number increasing, the difference between the adjacent orbits, this is nothing but the distance between the adjacent orbits. This is the distance between the adjacent orbit which is decreasing. If you see here, this is more when compared to that of this one, this is more when compared to that of this one. That is nothing but represented here as E2 minus E1 is greater than E3 minus E2, greater than E4 minus E3. You can see it here. Fourth postulate under the Bohr's atomic model is as long as the electron present in an orbit, they does not lose energy or gain energy, hence these orbits are called stationary orbit. Remember, as long as the electron is in a particular orbit, it neither loses energy nor gain energy. When it is not gaining or losing energy, it will be in that orbit only. So that orbit for that particular electron is considered as stationary orbit. The next thing is the angular momentum of an electron is quantized. Remember, as per the Bohr's atomic model, the angular momentum of electron, you know, the electron revolves in a closed path which is similar to that of the circular path. As the electron is revolving around the nucleus in a closed path, the angular momentum of an electron is quantized. The angular momentum is always an integral multiple of h by 2 pi, or else you can say it as nh by 2 pi. Here we have represented the angular momentum of electron. Angular momentum of electron mvr is equal to nh by 2 pi. Here m is nothing but the mass of electron, v is velocity of electron, r is the radius of orbit in which the electron is revolving, and h is Planck's constant, and n is integer 1, 2, 3, 4, so on. The last postulate under Bohr's atomic model is energy is absorbed or emitted when electron jumps from lower to higher orbits or vice versa. The energy is equal to the difference in energy between the two orbits which electron jumping takes place. Here if you see, whenever an electron is jumping from lower energy level to higher energy level or else lower orbit to higher orbit, what happens is the energy is absorbed. When an electron is jumping from higher energy level to lower energy level, the energy is emitted. This absorbed or emitted energy is equal to the difference between the energies of two orbits in between which the electron jumping takes place. The difference in energy is mathematically represented as E2 minus E1 is equal to h mu. Here E1 is energy of the first orbit, E2 is energy of the second orbit, mu is frequency, and h is Planck's constant, whose value is 6.625 into 10 to the power of minus 34. Lastly, the demerits of Bohr's atomic model. Bohr's atomic model could only explain the spectrum of hydrogen atom and ions similar to that of a hydrogen atom, or the ions which are having only one electron. It could not explain the spectra of the ions or atoms more than one electron. The other demerits of Bohr's model are: it could not explain the fine structure of spectrum, it could not explain the Zeeman effect and Stark effect, that is, the splitting of spectral lines in presence of magnetic and electric fields. Let us summarize once again Bohr's atomic model. Electron revolves around the nucleus in a specific path known as orbit, energy level, or shell. Each shell or orbit is designated as 1, 2, 3, 4 or KLMN. As long as the electron is in a particular orbit, it neither gains energy nor loses energy. That particular orbit for that electron is known as stationary orbit. Angular momentum of an electron is quantized. It is always the integral multiple of h by 2 pi. And when an electron jumps from higher energy level to lower energy level, the energy is emitted. And if the electron jumps from lower energy level to higher energy level, the energy is absorbed, which is equal to the difference between the energy of two orbits between which the electron jumping takes place.